Welcome to Data Hurdles, a weekly podcast where we explore the impacts data and technology have on our day-to-day lives. My name is Michael Burke.
And I'm Chris Detzel. All right. Well, welcome to another Data Hurdles. I'm Chris Detzel and
I'm Michael Burke.
Michael, how are you today?
I'm doing well, Chris. It's been a busy day, Monday, a little off our routine of our recording date, but it's good. Excited to be here. And today we're going to talk about
data pipelines. And the way to kind of see data pipelines, for me to understand it, I had to do a little bit of digging. And this one guy put it, it's out on YouTube. Maybe I'll push it out into the notes. But basically he said, look, it's very simple. It's kind of like, you have your lakes, let's look at water. You have your lakes, you have your oceans, and you have some rivers, right? Right now, it's just dirty. You can't drink it. You can't take a shower in it. You can't do anything. I mean, you could go for a swim or something maybe, but then from there, to be able to make it drinking water and to make it clean, you have to build these pipes that really go directly to like a treatment center. So this treatment center will enrich, clean, do all these things to allow you to drink the water, to wash your clothes and things like that, or to even send it out to agriculture kind of stuff, grow your corn and all that kind of stuff. And there's pipes for each one that allows you to do that. And today we'll kind of talk about that, but how data and data pipelines kind of relate to getting clean water and enriched and that kind of stuff. What do you think, Michael? Is that a good way to say it?
I love that analogy, Chris. I think that's awesome. And in many ways, if you think about your utilities, right, there's an entire world dedicated to getting your water clean and delivered to your faucet. And it's the same exact thing in the data world, right? There's an entire world of plumbers, or what we call engineers, right, who are focused on maintaining and governing and facilitating and cleansing this data. And today we're going to dive a little bit deeper into what the heck that is, how it works, and what do we do with it, right? And especially a little tip of if you're new to this space and trying to get involved and do something with data, you have to know pipelines, right? You have to know how to plumb. So we'll dive into it today, starting off with why do we build data pipelines, right? Why are they important?
Well, before that, tell me your definition of what do you think or what is a data pipeline anyways? I mean, I kind of give an analogy.
Sure. Yeah. So when you think of a data pipeline, you brought up like the ocean, right? We call that just raw data. In the real world, you got data that comes from mobile devices, from websites, from all these different third-party locations, IoT devices, and that all has to be put somewhere. And it gets put into this raw state, either in like a S3 bucket or some sort of storage, but it's not organized. It's dirty and it needs to be cleansed and enriched and shipped to different places. And the process of shipping that data is what we call a data pipeline.
Great. So why don't we build them? What's the point?
Yeah. So, I mean, like I just said, right, data starts in a raw state and then it moves into this clean, enriched state downstream, right? And we use this word downstream a lot, meaning, you're coming from an ocean of data, moving down the stream to eventually the consumer of that data, which we don't use the word faucet, but we probably should, right? And these pipelines, they're not just shipping the data, they're typically doing things to the data to make it more consumable as well. So we talked about cleansing, there's also filters, masking. We're going to go into a little bit more detail of each of these things, but aggregation, standardization, and really at the end of this pipeline, you have this analysis-ready form of easy to consume, easy to understand information that can be used to drive a business process or make a critical decision.
So what are some of the different parts of the data pipeline?
Yeah, absolutely. So there's three main pieces to any data pipeline. Like we're talking about data coming initially from a raw data lake or ocean of data, and that would be considered the origin, right? Where did this data start from, and what does this pipe need to connect it to? So an origin is really the point of entry for data and all data sources. So we talked about IoT devices, sensors. It's wherever that data originated from.
Okay.
It could also be things like data warehouses or data lakes. And a data pipe doesn't necessarily have to start at the beginning of wherever that data originated from initially, like where it was created. It could be any stage, right? So and then there's the other piece, which is the destination, right? Which is the final point at which the data is transferred to. And that's, depending on the use case, can vary. It could be somebody who's consuming the data, or it could be going to another business process to do something like cleansing or cleaning.
So let's spend a little bit of time on that, because I want to understand that a little bit better. You said it's the final point in which data is transferred. So like where? To like a BI kind of platform to show the data, of what's going on, like a dashboard or whatever, or no?
It could be, right?
Okay.
It's think of your water analogy, right? Water comes from the ocean and then it goes to a treatment center, and there might be rivers and streams in between there. All these things are connected, right? A data pipeline is the process of connecting from point A to point B. So it's not saying that it's going right from the ocean to your faucet, but it's going from one point to another, and that's the origin and destination.
Okay.
And then finally, the last part is the data flow, which really is the movement of that data, along which like transformations are taking place, different processes are taking place. And we'll talk a little bit more about that when we dive into ETLs.
So can you give some like examples of, the types of pipelines that, exist?
Yeah, absolutely. So there's two main different types. There's multiple, right? But we're going to talk about the two biggest ones. Batch, which is when data lands into a source incrementally, right? So when we talk about a daily batch, it means a chunk of data was shipped from one point to another on a daily basis. And this is typically where that extract, transform, load ETL process is performed, which we can talk more about. And then there's real time. And real time is using services like Kafka or Lambda, which is a serverless compute, or other tools from Google and Azure, Google Cloud Functions, right? And what they're doing is shipping data in real time. So every piece of data that comes in, somebody clicks on your website, that one piece of data is shot over to the next service without waiting for anything else. It's not incremental.
So those real-time technologies that you mentioned, like Kafka, the other two, they're similar. It's just a preference of what that company or whoever wants to use, or?
Yeah, there's some differences, right? But they're all doing the same thing of shipping real-time data.
Okay.
Right. Lambda and some of the common cloud functions are what we call serverless capabilities.
So what is serverless computing anyways, or what are those? What is it?
Yeah, so we're kind of going a bit off track, right? But like you
my
think
bad.
of no, it's good. It's good. When we think of serverless, right? Traditionally, when you run software to do things to data, you have to have a server or a computer. It's a fancy way of saying computer that runs those processes. Serverless is this thing that originally I think was introduced by Amazon in 2014 or so, but I could be wrong there, where you're not actually paying for a computer to run something. You're just paying for that one function to transform that one piece of data, and that's it, right? So if you think about like a good analogy is the difference between renting or buying a car, right? When you buy a car, you have to put a deposit down, you have to pay your monthly installments, and you have to own this device, which gets you from point A to point B. When you use serverless computing, it's kind of like renting a vehicle, right? You're only paying for it for that period of time that you need it to get you from point A to point B.
Got it. Anything else on the serverless computing stuff, or no?
Yeah, I mean, I think the biggest difference is that a cloud provider manages that server for you, and that's why they're able to charge you versus you owning a computer that you run or manage yourself. And really all of this is to help facilitate what we call ETL, which stands for extract, transform, and load.
Yeah, you mentioned that earlier, so I guess we can go into that now.
Yeah, so extract, transform, and load, and there's a bunch of different variations of this, is really the process of extracting data, transforming it in some way, and then loading it into another system. So this is like a process that happens in most data pipelines. A really simple example would be you've got, let's say, clicks on your website, like people clicking on a certain button, right? Mm-hmm. All those events are coming into you through a data pipeline. And through that data pipeline process, we might be transforming or calculating the aggregate of those clicks, saying, all right, 10 actual clicks have come in. We're going to send you the number 10, saying that that's the amount of clicks, right?
Yeah.
And so really, the different pieces of ETL, extract is, the process of gathering all the data from these source systems. Transforming is converting the data into a format suitable for some sort of analysis or to be used by some other system. And it's not just about doing things like aggregation, but also filtering, deduping, cleansing, validating data, calculations, performing summarizations or calculations, encrypting information or masking it for compliancy and governance processes, or formatting the data into a place or form that's easier to be consumed. And then finally, load is just the process of, after we finish that, where do we save the data? Where do we store it? What is that destination?
So quick question on, the people that manage it, I assume it's, data stewards or engineers. How do they manage that data pipeline from a day-to-day basis?
It's incredibly complex, right? They have to build monitoring tools to monitor how this data is and at what frequency this data is coming from point A and headed to point B. You think about your utilities providers, going back to that analogy, because I love it, right? It's not like the water treatment plants are just launching plants and then never monitoring them or maintaining the quality of water going into your drinking system. There's a whole team responsible for making sure that there's the right pH and there's not bad bacteria. And they have all these systems in place to make sure that the quality of water that ends up in your tap is of certain standards. And the same thing happens with data pipelines, right? There's these governing tools, and we use things like Splunk or Grafana. There's, catalogs, all these other systems that we put together in order to monitor the quality of data and making sure that we're delivering high quality data.
It's funny as I kind of think about all these things that you're talking about. It all makes sense. I get to hear this on a daily basis at our current jobs, and the way you're kind of putting it together for me, it's like, oh, that's what Splunk does. But what's crazy about this, and that's just kind of the way it is when you look at like the water treatment, the water pipelines and everything else, there's different technologies or things you have to buy to make sure all this stuff is running correctly and stuff like that, right? Like, so it's the same with data. Like if you look at it as, well, if you want good quality water, or good quality data, you're going to have different technologies that do these things. Like you mentioned, Splunk to kind of just monitor it. You might need a Snowflake to kind of not host it, just have that.
Store it, or do things with it, right?
So it's just, it's starting for me to make more sense. But, before you would say Splunk and, all these different technologies. And I'm like, I don't know what the hell any of them do. But now it really is starting for me to make more sense, for somebody that's not so technical. So I think we know this, but I still think it should be asked, what are some of the advantages of a data pipeline? Pipelines.
There are so many, right? Think about, without a pipeline, you would be stuck with data all in one place and not able to ship it or do anything with it, right? But diving into the actuals of a data pipeline and well-structured data pipelines, they provide an increase in data quality, right? Data can be monitored, it can be governed, Data pipelines also unlock incremental builds, right? Where they allow users to create different data flows for different purposes, right? Not everybody uses water for the same use case. Most people use it to just drink out of it and do their laundry or whatever, but there's commercial use cases. People need water in different quantities. It's the same thing with data, right? Data stewards and data engineers are managing and maintaining and customizing these pipelines for different use cases.
Does that have anything to do with, like, when you go back to people use it for different things? So like data virtualization allows you to pick and choose what data that you want to use, and that kind of, is that right? Or is that kind of?
There's some of those things for sure. Like not everybody should have access to the same data, right? In an organization, there's trusted stakeholders, there's external parties, there's internal parties at different levels, there's business stakeholders.
Yeah.
And so all these pipelines are designed and governed differently, right? And you know, one of the other advantages to using pipelines is that it's repeatable, right? There's common templates that can be reused and repeated to create the same type of delivery systems for shipping data. And typically, if that's architected correctly, you also have these standardized monitoring capabilities, which are layered on top of that. If you go back to that water analogy again, like the water treatment centers all have to talk to each other, right? There's flow issues, there's quality issues, and it's not even at a state level or a town level or city level. It's at, you know, as far as it goes till the data gets to the ocean, right? National levels that they have to worry about these things. It's the same exact thing with information, right?
Yeah, no, that's good. What else? Is there any other kind of takeaways or thoughts?
I mean, I think that one of the disadvantages, we didn't talk about disadvantages of pipelines, as in their own, just as a pipeline, right? All it is talking about how we ship and transform information from one point to another. But one of the big challenges and disadvantages is without the proper structure and organization of these pipelines, things can quickly spin out of control, right? One data store does something one way, another one does something another way. They ship data in different ways to different people. There's a huge amount of communication and architecture that needs to go into designing one of these systems where data is managed and controlled and governed by a larger body. And that's where it's an advantage, but also a disadvantage, right? Things can go drastically wrong. And when you see a lot of these companies that are having trouble or failing to leverage data to their advantage, it's because there was nobody controlling that ecosystem. And if you think about like MDM and some of these other tools, they work as a platform to govern all these pipelines, right? And to standardize. So we can say, hey, there's a centralized unit across all this chaos that's going to consolidate and standardize these pipelines in a way that provide governed, high consistency, reliable data.
No, that was good. And, you know, I have some off the cuff questions I'm going to ask you. And if you can't answer them, you can just say next question.
No, go for it. Let's do it.
Okay. You know, this seems really big, you know, like one is how do you start? And then, you know, how do you start looking at the right tools to implement for, you know, building a data pipeline? It just seems big to me.
Yeah. I mean, it is big. It's massive, right? I mean, the biggest steps, if you're starting off in something like this and you're trying to build your first data pipeline, you're an engineer, I think the biggest thing, the biggest takeaway to start with is do your research. Understand if you're in a larger organization, what is the current ecosystem? How can you contribute or play with that ecosystem? But also really clearly define what are your business objectives in building a new pipeline, right? Is it scalable? Will it be reusable? What's the effort required for it? Who's going to manage it and own it later? You know, what happens if you leave the organization? Is there a standard practice that can be followed? Somebody else can take up that work and it doesn't just become this unmanaged system. You know, in more complicated pipelines, identify the processes in your pipeline and the interdependencies with other components, right? Reusability is so important in this space. You're creating systems that are automated, that should be as self-sustainable as possible. Um, you know, establish a process and a schedule, whether it's real-time data coming in or incremental. How is the information going to come into the system? Make sure that that's a repeatable, consistent pattern in whichever schema or choice that you choose. And then again, really just make sure that you have thought about and articulated how you're going to monitor the quality of that data as it flows through a system, right? You need to be able to spot potential issues, do integrity checks, make sure security protocols and governance are being followed, and start by asking the right questions, right? This is a complex space, and it can easily be something that without involving the right people and asking the right questions, you're actually doing the business a disservice.
Yeah, that's good. And maybe have you ever like designed a data pipipeline or developed one?
I have. And when I was first starting out,
what did that look like? Yeah, when you first started out.
When I first started out, I did exactly what you shouldn't do. And I designed a data pipeline on my own with my small team. And we did it in a silo, right? And we did it without monitoring involved. And we plugged in production processes without informing the right parties. And we broke things. And it was so painful. We spent nights and weekends, running behind the scenes, trying to build in this testing and monitoring and governance and standardization after to keep up with the demand of this pipeline that then couldn't be turned off because people were reliant on it. And I think that in especially small to medium-sized companies, but even larger companies, this is a problem that everybody struggles with.
For sure, especially larger companies.
Yeah, and especially the organizations, at every level you run into these problems. And it's a trade-off between how much do you want to standardize, which is slower and more political and takes more time, versus just getting something done and breaking things, right? And definitely, when I look back on these choices, I would start to measure and really try to have more forethought of who's going to actually consume this data and what is it going to be used for? Is this something that if it breaks, the whole company is going to go down for a period of time, or is it like a customer may not get an email that wasn't very important to them, right?
It's when you hear engineers like, just let me build it. We don't need to buy this. It's like,
yeah. And using managed systems, unless you have the experience and knowledge to build them yourself, and you've gone through this process, I would highly recommend going with a managed system because there's so much unrealized work with building things yourself. And it is worthwhile in certain use cases, right? If you're a super large organization and you know how to build and you've got the right people who can maintain building out the most complex pipelines, right, for a specific use case, by all means, go for it. But make sure you know what you're getting into because there is so much hidden work and pain and stress with not using a managed system. And even with a managed system, you still run into these challenges of someone has to maintain it, right? And be watching these dashboards and processes to make sure they're working.
Yeah, it's maybe, I don't know if I completely agree with the statement of, if you have the expertise, do it. Just because those expertise people leave at some point, and so, if somebody built something from scratch, a technology or, a home built technology, then somebody else is gonna have to learn that, and then it just becomes way more complex when if you had like a SaaS or something like that already there that can already do the work, I mean, to me, it's my own personal, I know engineers don't believe that.
So Chris, just let me interrupt you really quickly. Yep. When I say build a system, do not build a system with one person ever, or even a small group of people. If you're going to build a system, think about it like a product, right? You are building a product that needs to be maintained and supported by your customers, which could be internal or external, but it is a product, right? And you have to think about it that way, because if you think of it as a function or something internal that you're going to walk away from in 5 years or whatever, you're just doing the company.
Nobody thinks that though. They think, oh, I can build this cheaper, and maybe it's cheaper for the first few years, but as more and more data comes in, and can it handle it? What are you having to do to kind of maintain it and stuff? I don't know. I mean, I'm very leery I'm like, I don't know if that's ever the right decision. Maybe. So something that you're very good at and know a lot about is data quality. How do you ensure when you look at, you mentioned this a little bit before, but like how do you ensure like data quality and reliability in data pipelines? How do you make sure it's good? What's the things that you have to do, to kind of when you're monitoring all that stuff, I don't know if that
Yeah.
makes sense.
No, it does. I mean, it's a huge kind of open-ended question, right? It depends entirely on the data and the use cases. So if you're thinking about any pipeline, start with the consumers. Who's the consumer today? And what will the consumer look like in 5 to 10 years? What are the other possible consumers within the organization or outside the organization that you want to account for when you're building this thing? And then step back from that and say, okay, what would they care about, right? How much are they going to build on top of it? It's like predicting the weather, honestly. It's really hard to understand and know what things will evolve to over time. But if you start
Yeah.
with at least a preface of this is your hypothesis of how this data will be consumed, or this is the only things that we're going to allow people to consume it for, if you're in more of a governed, controlled body, then you can build your data quality on top of that, right?
Mm.
And I always look at data quality as everybody says, oh, well, we want the best, highest quality data and should never make a mistake. Sure, in an ideal world. But when you have competing priorities fighting for your time, you have to make an informed decision based off of the use cases and the risk associated and the cost associated with that data running into issues with it later on. So if it's a very low risk thing, you might not need to put as much infrastructure and thought into the quality. If it's something that is critical to your systems, make sure that you're going through the process and the rigor of looking at every detail of that piece of information and splitting it up in different ways. Like to give you an example, because I think that's what you're looking for.
Yeah.
A simple data quality check could just be, is the data coming in, right? Is it coming in? Great. The data is coming in at the same time. We don't care about what's coming in. We just care about it's coming in. If it's something that is driving the whole business, classify the data, break it down into subcomponents. Is the same shape of data, type of data coming in? Is the same variation of data coming in per day? If it's customers, you probably want to understand, like if it's registrations from customers, are they coming in from a distributed geographical location, right? Are they coming in at all times of the day? Are they coming in doing the same actions, or are they taking different actions, right? You probably need to seam a lot more together to define what does quality really mean. So yeah, it completely varies, but
Feels so nebulous, Michael.
It is a bit nebulous, right? Because I mean, think
your
about
data quality can be different than this definition, and pipeline is a little bit. I don't know, man. It's tough.
Think about if the supplier of water, going back to that analogy, had 1,000 different types of water, and you said, tell me what quality means to supply 1,000 different types of water. Well, it'd be difficult because there's probably 10,000 different ways that those different types of water can be used, right? All right. And so all of a sudden you've got this problem where you're looking at all of these use cases that may have different variations of the definition of quality, what is valuable to them.
Yeah, I would think that the more an expert does some of this stuff, I mean, they can really understand the use cases eventually become, okay, this is what we need. Like when I go and build communities, for example, I know exactly what to go do inside an organization to build that thing. Yes, there's different ways to do it. But same thing as data, like even me trying to get the data out of my platform to stream over to Tableau. It's just, it's hard enough to do that.
Exactly. I mean, if you think about like the textbook, what is data quality, right? What are the metrics people often give? It's like consistency, accuracy, completeness, timeliness, validity, and uniqueness, right? And so those sound great in theory, but what does accuracy mean? It's essentially the same thing as quality, right? When we talk about accuracy or when we talk about validity, right? It depends on the context of the data.
Somebody did say on this one piece of data, how accurate does it need to be? I was like, well, it came out here and it needs to come out that way. Well, we can't really do it like that because it's going through this, from here to Google BigQuery to Tableau to Sales, all that stuff. And I'm like, all right. So yeah, that makes sense though. I got two more questions for you. Hopefully,
Yeah.
so far so good. You've done really well. So thanks for bearing with me. But when you're building some of this stuff, what are some common challenges when building and operating a data pipeline, and how do you address that?
Yeah. So especially if you're starting from scratch, I think it would be thinking about those systems. We talked a little bit about that, right? Working backwards from that problem statement, identifying all the problem statements. One of the things that is so common, and this is at every level, not just people that are starting out, is you build something, you build a data pipeline, you build data architecture, and you build it for a scoped view of things, of consumers, when in actuality, there was a lot more people within the organization that wanted to use that data in different ways. And you have to then think about, how do I make it bigger? Do I need to build a separate data pipeline for them? So making sure you talk to the right stakeholders ahead of time, and representing them when you make decisions. And this is at the large scale. I mean, at the smaller scale, thinking about things like, how do you enable people to create their own and do their own analytics, where they might be able to create their own small pipelines for low risk activities, distributing that work, right? One centralized team cannot effectively run the entire organization. There's just too many needs and too many use cases. So how do you democratize data a little bit while maintaining control on the pieces and the pipelines that really matter, that if they went down, the whole business would be, in trouble. So I think that's, when you start thinking about, like, what is the scope? What is the cost? What is the risk? I would start with those types of questions, asking yourself those questions when you map something like that out.
I feel like a big challenge would be finding the right people and staying and all, people come and go in big or in any organization. So keeping that talent has got to be really tough. So, some of the ways to address that is maybe you're always hiring, or maybe you're always teaching and getting others to kind of cross learn, different aspects of, the data stuff. So if they have one job, well, maybe they spend 10 or 20% on this data pipeline stuff, or whatever it is, to make sure you always have the talent, I would think that's a huge one.
Yeah. That I mean, if you're talking about people management and distributing risk, absolutely, right? And in addition to that, I've seen it many different ways. Some people have rotating careers where 1 week out of the year, 2 weeks out of the year, you go try another job, so that there's some distributed understanding of how
1 or 2 weeks is not enough for this stuff, dude.
Yeah. I mean, but like, you think about it.
I hear what you're saying. Yeah.
Everybody has priorities within the organization, and the truth of the matter is, some of this is inevitable. There is no silver bullet that I've seen to date that says, hey, we are going to, take all the brain power out of the smartest people who built all this stuff and distribute it across the organization so that we never lose anyone, right? And we never have any siloed services that are running that nobody knows what they're doing. It just doesn't happen. There's too much work to be done. And there's a huge balance right now also between, especially in older companies, maintenance and distribution of existing systems and all the net new demands that are coming in from the business, right? So you've built these pipelines. As a data stewardship team, you have to manage them, but at the same time, you're getting N number of requests to build these new innovative things.
Exactly.
And so it's like, I always say the data stewards are the unsung heroes of any business, because they're kind of in this role where nobody really understands how much goes into keeping the lights on in an organization like that, and how much of a balancing act they have to take with their time and resources. And it's a cost center. At the end of the day, they make no money right off of this. So it's an unappreciated space, and it's difficult to maintain that traction, to really have a culture of a highly functional data org. And I would say that some of the companies that have done a better job at this, they force all of their employees to have a certain degree of understanding of data, whether that's knowing SQL or being able to ask the right questions, or leveraging self-service technologies. But putting some of that ownership on engineering, some of that ownership on the consumers of the data, the business stakeholders, and making everybody responsible for at least questioning and trying to own some piece of data quality, that's the closest I've seen to being able to create a sustainable system that will grow throughout time. Yeah.
And kind of the last question is to kind of bring this all back around to real life, right? You mentioned that, in our podcast, we're trying to make this a real life, that we talked about data pipelines and kind of what it means. And we sort of, put out some, water, data and water kind of being similar in a way, in the treatment that you have to go through to get clean data, clean water, et cetera. Any examples that you can think about from a company, or let's say a pharma, insurance, I don't know, retail, whatever space, that can give us from, hey, there's all this data here that is not clean, and this is kind of maybe not exactly how they do it, but it's maybe how they would do it to clean it, and then this is what they would use it for, I don't know, marketing or sales or whatever. Any thoughts come to mind from that?
Yeah, I mean, if we're talking about the actual technical steps of building a pipeline for an industry, a specific industry.
Or maybe it's not the technical, but it's more about garbage out to garbage, or to clean in, like it's all this garbage data into clean, and now they're using it to do this. I don't know. I mean,
so the biggest thing is really, you have to constantly remind yourself of the business value of data, right? As soon as a piece of data becomes a row and not a business concept, it's irrelevant, right? And that's when you hear this term data swamp, right? You had a lake and it turned into a data swamp.
Right.
It means you have unusable data that has no lineage, no context. And so if you think about like the takeaways of this, like what could somebody really do to create high quality data? The individual use cases are going to vary so much, it's not worth talking about right now. But what we could say is minimize the centers of data, right? Reduce the amount of centers, which means places that data gets stored and works as like a transactional facilitator of data, as much as possible. Always think about how you can centralize more of that, because having multiple redundant platforms quickly becomes costly and leads to inconsistencies and disconnects across an organization. Maintain data lineage. It's such a hot topic right now. Metadata, you hear this keyword all the time. We need metadata, right? As applications evolve, there's bound to have change, right? And change at who's touching the data, how it's being transformed, right? And you were just talking about this. Like, what if someone leaves?
Yeah.
Fields are added and depreciated all the time in every different level of this ecosystem. So by labeling the data with sensible descriptions and documentation, at least somebody who's new can go back and say, okay, we received this data here. It doesn't seem right. Here's all the lineage associated with what happened to it, right? Back to the ocean. Here's every change, every tweak that was captured along the way, so I can trace my steps back. And then, like, I would say finally, like, maintain data context, right?
Yeah.
It's so important to keep track of what the data is being used for and the use cases and throughput of those pipelines, right? So I would say let each unit define what quality means for them and what is the business concept of the pipeline, and then apply and enforce standards as much as possible, right? Before data enters the pipeline, once it's consumed, while it's in transit, and make sure that context is maintained as much as possible, right?
Wow. We now come to the end of data hurdles, but that was really good, Michael. I mean, I'm sure you're kind of wore out.
I love this stuff. I could go on for multiple episodes. I think if anyone has questions on pipelines, how they work, how to dig deeper, feel free to reach out to either of us. This is an exciting topic. It's always challenging, especially if you're new. So yeah, I hope this was helpful. And if anyone has any questions, feel free to ping us or shoot us an email and we'll do another topic on this.
That's great. Thanks, Michael. And thank you for tuning in to another Data Hurdles. Now, please rate and review us. We need all the ratings and reviews we can get. So I'm Chris Detzel and
I'm Michael Burke. Thanks for joining.
Michael.